So the first one says students in the introductory statistics class at BYU Idaho were studying prices of cold cereal at the grocery store in Rexburg. To get a sample of cold cereals, and they went to the Albertson and rolling the die, decided with the box left on the top shelf will start on. And they recorded the six cereals at the first, moving to the left to right down the shelf, recording the name, size, and price of cereals in their sample studying experiment and observational study. Why?
Okay, just to make
And
sure we did our category quantitative, right?
Right. Question two is,
oh,
I
Was
think it's
the
the
sorry.
third
last
one
the
only.
last one only, right?
Yeah.
Okay. All right. Now,
And then
Yeah.
this is an observational study. They're not experimenting with anything. And if they did,
Uh-huh.
there's no, they're studying the price. They had no control over the price of the individual cereals. Is that right?
Yeah, there you go.
yes, what's the
Or is
first
it?
So,
one?
That's the
Wait,
second one. So that's the question. So they had no control over which cereals were selected or over the price of the cereals.
what are they testing?
They're testing the prices.
Okay, then it's the price.
That's why I think it's the price. But I'm not
yeah.
sure.
All
Yeah,
right.
because if it can't be the first one because the first one applies to even experimental experiments, you know. On both of them, any random sample experiment, you can't control which ones you select. So,
Yeah, true. Okay.
okay, so for Math 221A projects, one group of students studied the ages of students in BYU Idaho campus. They collected data from a random sample of 100 students. The sample mean was 21.2 and the sample standard deviation was 2.61. An excerpt of their data is given below. So they have 1 through 99, male, female, male, female, male, female. And there's a 12-year-old, which is an error. Okay, the group notices an error in the data. The age of one of the males, ID number 3, was entered incorrectly. He was actually 21 years old. When the error is corrected, what will happen to the sample median? Not the mean, the median.
Mm-hmm.
Which remember, the median is always ahead of the mean. Wait, or the mean is always ahead of the median? Or,
Well, the median definitely gets pulled by those outliers. And that would be an outlier. So I would say the median's going to increase.
Yeah. The
it's what Christina's saying is that the 12-year-old is pulling the median towards the younger end of the scale. So
Yes.
changing it to a 21 will make it so that the mean goes back up to the more mature age. Okay,
Yeah. So the median will increase.
so sorry, I'm reading all of these. That says the time to complete a standardized exam in BYU Idaho Testing Center is approximately normal to with a mean of 70 minutes and a standard deviation of 10 minutes. Using a 60, 95, 99.7 rule, approximately what percentage of students will complete the exam in under 50 minutes? So the big chunk of all the data is in the middle. So the 68 is is
Yeah. The
70 minus
68,
10.
right, will be between 60 minutes and 80 minutes. 68% of the data will be between 60 and 80.
So it's plus or minus 10 of that 70 mean.
Mm-hmm.
The next chunk of it will be another plus or minus 10. So now we're looking at 20 plus or
Right.
minus.
So between 50 and 90 minutes, 95% of the data will be there.
So we're going to say 9.5.
so
So,
did they want to give us the answer in one decimal?
but
One.
listen, the question is approximately what percentage of students will complete the exam in under 50 minutes?
Oh, it's even one
So it's
more.
less than that. So 95% will complete it between 50 and 90. And then under 50 and over 90 will be the rest of it up to 100. So that gives us 5% to work with. So I figured the under 50 would be half of the 5%, which is 2.5%. If we had to estimate.
Okay.
But it has to be 2.5%. That, yes, it's in percentage, right?
Yeah, I'm a little confused because by the time I get to the 99.7, I'm already covering like 90 minutes worth of exam taking. Oh, I see. They're getting what's under 50. So that's gonna
Under
be
50.
so it's gonna
So it's
be
what's left after 95.
so I just take 95 minus 68.
No, because what you have is 68% of it is between 60 and 80. Including the 68%, the 95% is between 50 minutes and 90 minutes.
So
So
4.7.
so then what you have left, so ignoring the 99.7, because
Okay.
we're already at our 50 minutes. We kind of end up with a two-tailed thing. We have everything below 50 and everything above 90 will, and everything else will equal 100%. So 100 minus 95% equals 5%. But half of that will be, approximately half of that will be less than 50, and half of that will be over 90 minutes, is the way I see it. Does that make sense?
Okay. So you're saying since each one of these little rule thingies is one standard deviation,
Mm-hmm.
we have to do two of them to get to 50 on one side and then 90 on the other side. Because it's one standard deviation would have been 60 and 80, and then 50, 90, and that's where we stop.
Right.
With the 50.
Because we want what's less than 50.
So, wait, how
Statistic.
did you get the 5%?
So let me show you just what I drew.
Oh, you
Is my
drew a
picture
picture.
going to show up?
Oh, you have to click on the video thing on your computer.
Yeah, I'm using my phone. So, okay, there we go. And switch it around. I don't want you to see me. Okay. So I printed this up last night because I had to work on paper. So if we have here between 60 and 8, okay, so we have our median or our mean. So the
Okay.
first, all of the data, 68% of the data is going to fall between 60 and 80 minutes. Now, 95% of the data is going to fall between 50 and 90. All of this will be 95% of the data. Everything past here and everything past here will be 100% of the data. And so we want to know what this is. So if this is 100% and this is 95%, then this plus this must be 5%. And half of that would be 2.5%. That's how I got mine. That's the way I'm thinking about it. And I remember getting these questions at the beginning of the semester, but I don't remember how they went. So does that make sense? Because this is 95% here. So everything else on both sides would equal 100%. And so 100 minus this leaves this and this as 5%. And that would be 2.5%.
Except there's a problem. One more standard deviation. Oh wait, we don't have to take care of it. We're trying to hit 50. Never mind. I got it. I corrected my own
Because
thought.
if we could go to 40, and then that would be, but that still doesn't go all the way up to 100. That doesn't give us the full amount that we need to deal with. That
Okay.
doesn't give us everything under 50 minutes.
That makes sense.
And I mean, I'm thinking it says approximately, so I'm going on that.
Okay. 2.5%.
I think. What do you think, Evelyn?
Yeah, that's what I got. I think is that's what I remember now what we did, and I remember that class. I remember when we did it. So and I got confused. I got 5% first, and then because was less than 50%, and then I say why is not 5%, and then I mess it up, and then
Holy.
finally I get it right. I remember that.
Okay, so yeah.
Okay, so this is actually a 47 question quiz or 45.
Yes. And it's
I
straight out of the
know.
review. It's straight out of the review.
I'm confused. I
So,
thought next week was the review.
no. Next week's the
Next
This
week
exam.
the exam.
wait, and then we're done with this class?
Yeah.
Yay.
This is it.
Yeah.
Yeah.
Oh, this is scary. I thought I was going to see you guys one more time. Now I need to pay attention.
Well, yeah, I didn't even look. Is there no more group meetings?
Yes, I thought there was one
No,
more.
I don't. That's what I was going to say because I wanted to post the lesson 24, but there is no link to it. So I will post it in the question and conversation again.
Oh, okay.
So it's always happening. Every time that we have a test, there is no place for the 24
Yeah.
collaboration board. So if
Yeah,
it's
it just
not,
probably means we don't have to post it.
Yeah, probably.
oh, I've been posting it in the student conversation.
So everybody can see our faces.
Okay.
Okay, should we go on to number 6?
I
So the
suppose.
score of the LSAT are approximately normal with the mean of 150.7 and a standard deviation of 10.2. Queen School Business in Kingston, Ontario requires a minimum LSAT score 157 for admission. Find the 35 percentile of the LSAT score given the answer
Ugh,
in the decimal place.
I forgot how to do
The
this.
applet.
This is
So
an
the
So
thing,
what
applet.
the
I
tricky thing about this one is they give you the Queen's School of Business thing, but I don't think we use that information.
yeah, they
I
like
All
to
think,
do
we
that.
all we use is the standard deviation and the mean.
yeah,
Yeah.
you find the 35th to find the 35th percentile. You go into the applet and put in
0.25.
35% and highlight the left tail,
Okay,
and
hold
then
on.
that'll give you the Z score. And then so now we have the Z, and
Which
we
one you're
plug it
in?
in and solve for X in the Z score formula.
Okay. I need to write this. So I use my normal probability applet.
Mm-hmm.
Okay,
So
2
and then you have to use the formula that
percentile.
is an algebraical formula that you have to turn around. It will be minus 0.3853 times
I got
10.2
385.
385. Oh, okay. Because I thought that we needed to do all the rounding at the end. But yeah,
Right. I got minus. I mean, the applet for me says point zero. I mean, I'm sorry, minus 0.385 is the Z score.
I got
yeah.
negative point. Okay, question. Why is it the left side of the.
Because you're looking for the 35th percentile.
Oh, duh.
So
Okay.
it
All right.
goes up.
Yeah. Plus 150.7. So that will be 146.8.
So then I get a z of negative 0.38 something.
8.5 is what I've got.
Okay, and then I solve for because negative
X.
0.385 equals
Mm-hmm.
my the x divided by So it's x bar minus mean.
Yes, minus the
X
mean.
minus the mu divided by the sigma over the square root of n.
But no n. We don't have, this isn't one where we're taking a sample.
Oh, I think I got the wrong equation.
So no, you're right. You're right. So it's just over sigma. No square root of n.
Oh, I see. This is
The
way
very
back.
first one. Yeah, very first one.
Whoa. This is humble beginnings, guys. See that?
Well,
I
it's
didn't even
because
know I
we're
did
gonna.
that. I took notes on that.
That's super good.
Negative 3.85, 0.385 equals x bar. Solve for x. All right. Perfect. Use the applet. Huh. Well, I guess I did use it.
So Evelyn, you said you got 146.8?
Yeah.
Okay, good. That's what I got too.
Okay. A team of dermatologists, researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were part of the research team to take a sample of men from this age group to calculate the mean number of skin cancer spots in the sample. Also, suppose that it is known the distribution of the number of cancer spots is right skewed. Suppose the sample size of the study was 2. Well, that's a really small sample size. It's still going to be right skewed.
See, this was one that I didn't know. I couldn't find anything definitive. It just said basically, I mean, I don't know.
This is
Maybe
where
those two could
central
be normally distributed.
no this is where that law of large numbers and central limit theorem stuff kicks in,
Right.
because you could have a right skewed, I guess, sample, or sorry, a right skewed population, but if you take more than 30 of those right skewed populations, you will get normal a normal.
Right. But nowhere in the book does it say the opposite. Nowhere in the book does it say a small sample means it stays right skewed.
Oh, I
That's where I
see.
was like, oh, I don't, because remember we had that one thing where we would hit the button and the little blocks would fall down and it would show that it was, normally distributed. It's like, yeah, but what if you hit it and the two blocks that fell down were normally distributed? I don't know. So yeah, for me, it was either skewed right or we can't be sure until we examine the data.
That was
Yeah,
the
it's skewed
homework was.
right. Naked. Where's your clothes, little guy?
Got his shot.
Oh, you got shot. Oops.
Oh, that's not fun. Okay, skewed right. That works for me.
Okay.
Okay, this
So,
was another one that was kind of weird for me. I wasn't quite sure.
all right. It says tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. The factory that manufactures the tanks of the trucks claims to manufacture tanks with a capacity of 8550. That's 8,550 gallons of gasoline. The actual capacity of the tanks is normally distributed with a mean of 8544 gallons and a standard deviation of 12 gallons. Suppose that a simple random sample of 20 tanks was selected, and uh, and the sample mean capacity was found to be 8550, which is less than, wait, which is the actual mean. What is the z-score corresponding to this sample mean? Round your answer to 3 decimal places.
Oh my gosh, they fixed it. On the in the textbook, they have the wrong number. And that's why this question did not make any sense to me. They fixed it on here. Okay, good. Question 8, they fixed it. It used to say 8544. It's like, well, 8544 minus 8544 is 0. Okay, suppose it a simple random sample.
So your x bar equals 8550,
Right,
and your
because
mu,
that's found from the sample.
Your mu equals 8544,
Yes.
Yeah.
and your sigma equals 12. What else do
So
we
Sigma
need?
that
equals
will be
12 and n equals 20 because now we're with a sample mean. So now we do need to divide sigma by the square root of n.
Perfect.
so
Okay,
it
so
will
then,
it is 2.236.
Yes, good. That's what I got.
and that's what I would get if I put it all in my calculator.
Yes, you would.
Sorry, what was that? 2.246?
36,
No,
2.236.
yeah.
Okay. What is a probability that the sample mean capacity of 50 random selected tanks is greater than 854? Okay, so then we do 854 for X bar.
8540. Yeah.
Yeah. And
So
then
you're going to get a
five
negative Z score.
544 for the mean. The size, well, the sample size is 50.
And then you do your
Yes.
same Z, your same 12, except it's all divided by the square root of 50.
Right.
And then you get a negative Z score of
Minus 2.357. 0.22.
What did you get,
Oh,
Evelyn? Sorry, I can't
oh
hear you.
no, he was asking for the C score,
Yeah.
but
What
that
did you
is
get for your
normal.
Z score?
Minus 2.35, 35.7.
Okay. I've got a different one. Let me double check.
minus 2.357. And then I
I've
highlight.
got
Five.
I've got minus 2.344. So let me check my math here real quick.
Okay, and then I want to know greater than, so I highlight the right side.
Let's save that.
I think he's still going to get the right answer because it's pretty dang small.
Good.
Which
Yep.
one? For
Minus 2.357. You were right, Evelyn.
okay.
I messed up in my math somewhere.
Okay.
Okay, so what was the probability? Well, let me check here.
0.991.
Yeah, 0.990. Well,
Oh, really? That was the same one that I got already, so that's good.
See, that's what I was saying because it's so small.
Yeah.
well, number why is not- number question number 10. Which one of the following is the best describe the notion of significant of level of hypothesis? The probability of obtaining of the test statistics at least extreme one calculated as the test of hypothesis. The probability type error one. This sounds very familiar.
I
Yeah,
think it's
this
the
one.
Pharaoh one.
Yeah. So, guys, here's the thing. When they use the word notion, because it could have been a couple different things. When they use the word notion, this is what I did research on. When they use the word notion, they're talking about the probability of a type 1. That was the same language they used the last time we had this question, and that was the right answer. So the
I
second one,
remember that we did, and then we have to read it the
right? Exactly. And so that was the right answer. That was the answer that you had said, Evelyn. That was the right answer.
Good job, Evelyn.
Yes.
Okay, so question 11.
About
The,
that.
the height of young adult females in the United States are said to have a population standard deviation of 2.6 inches. The sample was taken of 85 young adult females at BYU, Idaho, and the mean was computed to be x bar equals 65.4 inches. Whoa! Which of the following? How big is 65.4 inches? I just didn't even know.
5'3". No, 0.4
Yeah,
inches.
0.45
5 foot
inches.
5.
Why people do that?
About my height.
The weather will do.
Oh, 65. 5'5", 5.4 inches. Gotcha. Yeah, that's about how tall I am. I'm normal.
I think it's the altitude then, because Christina lives in the mountains too.
Like people from Bolivia?
Are they short?
Yeah. Most of them.
No, five is okay. That's like normal, right?
5 foot, yeah.
Hey, my mom though, she's really little.
What you say that you are 5 feet? I don't believe you.
Yeah, Christina, I thought you were like five, maybe. I thought you were just taller.
My mom's 6 foot tall.
Holy
Oh,
cow!
oh yeah. My uncle's 6'6". I have lots of uncles that are really tall. My son is 6'2". So I'm the shortest in my family. I'm super short in my family.
You're always surrounded by these tall people.
Yes, towering over me.
Okay,
Okay, so this one is important. Mark all that apply. That I totally missed that when I was reading over it the first time, and so I was freaking out about which one to choose. And then it said mark all that apply.
it's just the third one though, so.
And the last one.
What? What? Okay.
They both say the same thing.
Oh, why they do that?
I know that's
Well,
what I'm saying.
this is this is better than my biology class. You know, they put something in the book and they put a totally different wording in the exam. Plus,
Yeah.
they will use the wrong answer for the things that you're studying in the exam. So you get confused and choose the wrong answer. So
Yeah.
mean.
I know. I hate that. It's awful.
That's very meany.
Hey, speaking of biologists,
My biologist. There you go.
Yeah. I've been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follow a normal distribution. The population standard deviation of weights of male beluga whales is sigma equals 125 kilograms, and the researchers feel comfortable using this standard deviation for their confidence interval. Are the requirements for the use of a confidence interval met?
well, we know
Explain.
sigma.
Yeah, so the confidence interval,
That's the
they have two things because here we go.
the
Sigma no.
data is normal.
It has to be a simple random sample, and the data has to be, the sample mean has to be normally distributed.
Yeah.
And it already says that both of those happened.
So the second one.
Yeah.
Yeah, because the data is normal.
Oh, this is crazy. We're only on 13. There's still like 27 to go.
We'll
I
get
don't.
there.
I know. I don't know how to do math. Okay. Okay. So an investor with a stock portfolio worth several $100,000 sued his broker and brokerage firm because he felt that the lack of this diversification of his portfolio led to poor performance in many years in a row. In effect, to avoid close public scrutiny, the firm agreed to settle the conflict in an arbitration panel. The arbitration panel compared the sample of 39 months of investors' return with the average of the Standard and Poor's 500 stock index. Oh, I hated this question. I remember now. Sorry. for the sample period in order to determine whether there was a substantial decrease. The data are recorded in here. Suppose that you are a member of the arbitration panel. Conduct a hypothesis test to determine if the investor's portfolio performs significantly worse than the performance of the S&P 500. Use a level of significance of 95% confidence. So this is one of
Zero point.
those uh,
I put it on in the app. I mean the Excel sheet.
The Excel, yeah.
the paired, not the paired, the one sample t-test.
So the first thing that they ask is for the 0. Sorry, did you ask something, Juan? I totally ignore you. Sorry.
I don't remember. Well, sorry.
Okay. So the value is on there on the one sample t test, and then will be 0.03. How many decimals? Three decimals. Three
What was it?
thirty-nine.
What'd you get, Evelyn?
0.0 39.
Oh, that's different than what I got. Hold on.
I got 0.041.
I got 0.019.
Oh well.
Okay.
All right.
But it's the one sample t test, right?
Yes.
Yeah.
And it's 95% confidence, and it is not equal to.
It's
Yeah, yeah,
less than.
no.
It's less
Oh,
than.
it's less than?
Yeah, because they want to see if the investor's portfolio performs significantly worse. So, for
Oh,
example, the hypotheses
yeah,
would
you're
be
okay.
that it was the same as the S&P, which is 0.95, and then the alternative would be that it was less than 0.95. Because in here, the S&P, it says the S&P has a known population mean return of 0.95. So the null hypothesis would have been that it was equal to 0.95, and the alternative would be that it was less than 0.95.
Oh, okay. Now I got the right answer. 0.019.
Yeah. Okay.
Did you two get
Yeah, that's what I got.
0.019?
0.019.
Okay. Okay, it says a financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent sampling or dependent sampling? This is dependent, yo.
Good job.
Because every husband or every wife that they examine has to have a husband.
Right.
Let's see if something in here says what I just said. Okay, the last one says every husband's income depends on some degree of his wife's.
Yeah, no, but it's dependent sampling.
Says
So,
he needs to select couples from his
Either
sample. Whether
the second or the third, but I think it's the
yeah, the
second.
second one.
oh yes, the wife is dependent on the husband being tested.
I'll
Okay.
go ahead and read the next one. If you want to open up that direct flight costs Excel, it's just a big story. Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Allie Henrik, a BYU Idaho student, wanted to determine if there is a difference in the price of tickets listed 90 days before a flight compared with 14 days before the same flight. For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination, again 14 days in advance. So use the file that thing. What is the p-value for this test?
No way. Oh, no. Okay, you guys ready?
So this one's paired.
Oh my gosh, it's so long.
Okay, so I got a p-value of 0.0956.
Yes, that's what I got. So 0.096. 0.096.
Okay, based on the result of the test, can I say? Well, I cannot. Because if it's low, I reject the null, but this is not quite that low because it's...
Right. It's still higher.
All right, so the first one.
Yep.
Yeah, the greater than the lot of significance.
Okay, we're almost done. Just kidding, but
You wish. Oh my
So
God.
17, I'm going to summarize question 17 because, again, it's a big story. This is that real estate one with the appraisers. So we're talking about that
Yeah.
paired thing again. The company selects a random sample of 10 homes in different neighborhoods around the city, independently asks each appraiser for an estimate of the home value. After they receive the estimates for each home, the company subtracts the value from the first appraiser from the value of the second appraiser. They create a QQ plot of the differences and see the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? And that is, so it's a paired data. The requirements are a simple random sample, and the mean of the differences follows a normal distribution.
yay, the third one. Wait.
Yeah, because they were determined to be normal.
Okay.
They figured it out with their QQ plot. So now what's their hypothesis test?
That mean 1 equals mean 2, or that mean 1 is not equal to mean 2.
So for paired data, there's always for paired data, the
Oh,
hypothesis
0.
tests are always the same, and it's mu d
That's right.
equals 0, and mu, because it's the difference, and mu d is greater, less than, or not equal to 0.
Okay.
So that would be the third one.
All right. So, suppose you create a 95% confidence interval for a main, and you get this confidence interval. You've been told to report this by saying, we are 95% confident that the true mean is between this. Exactly what does that mean? It means that there is 95, nothing about chance.
No.
This was an exam too.
Yeah.
I don't know if you guys remember.
See how it says
I think
chance on the
I did
first one? We do not click on that one because once we do a test, we are then for sure doing stuff. No more chances. It's for sure.
I thought it was the second one, but I think
Yeah.
I was wrong.
Second
But
one
you
as
will
well.
never know.
No, the second one was right.
I
Oh,
agree.
really?
Yay.
That might have
I
been
don't
the
know.
one where you had the right answer and I chose that one instead, or something like that. But just for the question. But I
can
always
tell
look
you
for
which
95% of
answers you have wrong.
95%. And that's always the right answer.
Yeah.
Okay. If P equals 4/5, what is the smallest value of N that satisfies the requirements for a normally distributed P hat?
Okay. 30. I'm just kidding.
So the
I'll say
formulas
seven.
are NP is greater than or equal to 10, and N times 1 minus
Yeah,
P is greater than or equal to 10.
Ah,
I'll say approximately 7 or 7. No, wait.
So you just say P times N equals 10, and you do 4/5 times N equals 10.
Mm-hmm.
So then
Just
you
solve for n.
multiply both sides by 5. So you get 4 times N equals 50. Then you divide by 4. N equals 12.5. So 13.
Yeah, 12.5. 13. Because you have to round it up. No? Oh.
Yeah. And then I do another one
Is
called.
is 13 or is 12.5?
I
Because,
think it's 12.5 because it doesn't say
well,
use
I
whole
mean,
numbers.
do you need to round it up? That's what I want. I didn't know. You don't,
I don't think
right?
so. It
Okay.
doesn't tell us to. So,
All right.
but then you have to solve for the other one too, just to make sure that's not a lower number because it says what's the lowest. But when you solve for that one, n
Wait.
equals 50. So 12.5. So question 21 is a tricky one. It's one that I missed before, and unfortunately, I can't remember what was the right answer. But I think I remember.
So, I think it was also test.
Is he okay?
Yes, his arms hurt. Or his legs
Oh,
hurt.
yeah, of course.
Yeah, he's not happy.
Poor guy. So 21 is your little brother has a career batting average of 0.233. You want to determine the probability that he will have a batting average of over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion p hat will be approximately normal?
So
So
I
here's
think
where it gets tricky. 0.233 is the it's the career batting average. 0.250 would be related to the sample proportion. So if you're using, it depends on if you use P or P hat. I think we have to use P,
yeah, that's what I.
which means that the conditions are not met because that's
Mm-hmm.
less than 10.
So I think it's the number, well, the 4, the number 4.
Okay.
Is that what you think, Christina and Juan?
So you guys made your P equal. Well, yeah, duh. Okay, never mind. I get it. So you
Well,
guys.
the thing is, there's two formulas. There's n times p is greater than or equal to 10, and there's n times p hat is greater than or equal to 10. But really, I guess all we have here is the p value. So we have to use that one because that's what's used for hypothesis test, which is what she wants to do. So I think it's the last one.
Okay. Geneticist takes a simple random sample of n equals 140 gamete sex cells for test of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of dog gametes to contain the male chromosome of 46%. Oh, I remember I did this. Isn't it like 1 minus 46%? Oh, yeah, that's how they get their p hat. Okay, the geneticist conducts her survey, calculates the p hat is 0.512. Which of the following is the most correct interpretation of the statistic?
The B, number B. Oh, the number 2 is that 52.2 of the eggs fertilized were with this gamete will produce a female puppy.
Actually, I think it's number 4. It's the fourth one. that 51.2% of the gametes in the sample have the male chromosome. And it's because I looked up again in the book, and when they were doing that PTC test, they said
Yeah.
that P hat number is the proportion of people in the sample who could taste PTC. So if we related that here, then P hat is the proportion of gametes in the sample that have the male chromosome.
Oh, yeah.
Well, then what's 46%?
46% is the population mean. 0.512 is the sample mean. P hat.
I
So
see.
P would be 0.46 and P hat is 0.512.
I see.
But interpreting P hat means that what she found was 0.52, 512 or 51.2% of the gametes in the sample. It's related back to the sample, have the male chromosome. So that one I'm pretty confident about because I researched it. Speaking of researching, researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, all those diseases. In the US, 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the n equals 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 decimal places. So for this one, they want the probability, so we need to find the z-score and then the probability.
The Z-score and the probability. I didn't understand why they want it. Because they
So
didn't
they
say
want the probability that fewer than 320. So we know that that's going to be a left-tailed highlight on the applet. And so they give us P, which is 0.45, and P hat is 320 over 750, X over N.
Okay, so p hat minus p over p parentheses 1 minus p all over n, and all of that square rooted.
Yeah, everything's square rooted all over N, yeah.
Okay.
The other one. This one.
Okay. Let's.
Thank
Bless you.
you. My n is 750.
Do you have recently? Oh,
Oh, and I did my math wrong the first time. So what are you guys getting for your z-score on this?
I got minus 1.5. 1.32.
I'm sorry,
Oh,
I couldn't hear you.
oh, sorry, minus 1.321.
Oh, crud.
Oh, 32. Yeah.
That's not what I got, but I keep getting a different answer. So let me do this again.
I got a minus 1.2848.
I'm getting 1.101 minus 1. Okay, hold on.
Okay, wait. I just did it. This.
1 minus 0.45 equals
Yeah, you're right, Christina. I just put the wrong number.
divided by 750 equals square root. Let's remember that one.
Oh, I see.
Okay, this is not working for me.
Yep, I keep getting the same one.
Minus
28482.
But it is supposed to be less than 320. So we shouldn't do it with 318 or 319.5 or something like that.
I keep getting minus 1.101. Is anyone else getting that?
So are you doing 0.4266 minus 0.45 on the numerator?
Oh, interesting. No, I am not. So I need to do that. Thank you. So minus 1.284.
Yes.
Is that what we're getting? Thank you. Hallelujah.
Okay, but we're looking for fewer, so we throw that into the applet. And we get 0.099.
98. Is that what we're getting? 0.098? Oh, no, wait. What am I doing? No, 0.0. Oh, 0.010.
Yeah.
Yeah, that's
I agree.
That's what you get, Evelyn?
what I got lost. What are you doing? Which one are you doing?
On 23, question 23.
Oh,
0.010.
oh yeah. I thought that you were doing 24, so I was.
No, I kept getting the other one wrong. So
Yes, 0.09 34. Well, 30. Yeah, 3. 93. Is that what you get?
oh wait, I got 0.010.
Well, how much did you round your
Oh
z-score?
no. I'm sorry guys. See, this is why I need your help. I'm telling you. 0.100, right? My probability is coming out as 0.0996.
That's why. Yep. 0.010.
But X has to be
No.
greater than 320, or it has to be because they say without the integer continue. Oh no, without that.
So I'm
zero
get so
point what I got without that will be 0.100.
yeah, 0.100. That you're right, Evelyn.
Wait, you guys mean 0.0100?
No, no, because that's less than 0.9. I messed up. So to round up, it has to go because the probability
Oh,
is zero. Yeah, go up one. I messed up. I kept rounding too low.
0.10.
Yeah, 0.
Because it has to be lower than 320. That's why.
Right. Yeah.
Huh. Don't know how to round.
Yeah.
And Z, it has to be lower than minus 1.28
Mm-hmm.
for 20
Yeah.
to 84. So it will be 0.0, well, sorry, 0.100. I keep getting confused. So that will
Yeah.
be the answer, right?
Yeah.
That's what we have to put in 23.
Yes. Correct.
Okay,
Okay.
then 24 is a tricky one.
These are very difficult, and then it should take whatever.
That's what she
um,
said.
So if you
It's not that hard.
yeah, if you have these hypothesis tests and the z-score is 1.334, the area to the right of z 1.334 is 0.91. Which of the following is the p-value for your hypothesis test? And you're going to double it because it's a two-tailed test. And so one tail is 0.91, so two tails would be 0.182. Is that right?
yeah, yeah,
Okay.
yeah, 0.182. That's the p value.
Okay.
Okay.
Gee whiz.
Suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure sampling distribution of X bar is normal?
Oh, this was one of the homework assignments.
I got this one wrong before. And so
Yeah,
I know that the
I
right
got it wrong
answer,
and then I got it right.
yeah, it
So,
is known that the distribution is normal. It says it right in there. So because of that, that doesn't matter the sample. Any n will do.
yep.
I don't know, guys. Okay, I'm ready to be done. A
I
study is
know.
planned to compare the proportion of men who dislike anchovies. I'm one of them. With the proportion of
Yeah.
women who dislike anchovies. The study seeks to determine if the proportion of men and women who dislike anchovies are different. A sample of 41 men were taken, a p-hat. Estimate for the true proportion of men who dislike anchovies was determined to be 0.67. The sample of 56 women were also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. So does that mean that there was more women who disliked it? Okay. Are the requirements satisfied? Let's see. Do we just do P? Wait, no, these are all P hats.
Oh, these are different.
They don't give us a total number of men and total number of women.
No, they don't. But they give you the true proportions.
Okay, so
I
I'm
think
just
it's the last one, if
point
I remember.
six
Well, I
seven.
probably wrong. Um, trying to
Huh, the
remember.
answers to here are different than the answers that they gave in the review in the book. So I got that the answer is no. They are not satisfied.
Yeah, that's what I think.
Because of the women. If you go 1 minus 0.84 times 56 women, it was less than 10.
Mhm.
So the fourth one.
Yeah, that's what I think too. And then I think it was in one of the tests as well.
Okay. It says a study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between the before and after scores.
Number
What?
two.
Yeah, so this is a
Yes.
pair of data. So it has to be mu D.
Oh, these are my favorite kind. Another Weight Watchers watched to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into two groups. One group dieted but did not exercise, and the other group dieted and followed the exercise program. For the exercise program, they used linear regression with percentage compliance, with percent compliance with the exercise program as the explanatory variable and the pounds lost in 3 months as a response variable. Pounds lost in 3 months as a response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean?
So this is from this week's lesson.
The predicted.
And the
Mm-hmm.
residual is the difference between observed Y and predicted Y. So if that's the case, then it means the observed, which would be his actual weight loss, the difference between that and his predicted weight loss, since it's a positive number, it would mean I think that the actual weight loss was more than what was predicted. And it doesn't have to do with not exercising because it has to do with being prediction. So I would say it's number 2.
Oh,
Uh,
Because
yeah.
residual is
So
the difference
yeah.
between the observed and the predicted.
Mm-hmm.
and you said it's positive.
Yeah, 5.5 is positive. So the observed must have been higher than the predicted. But they all say 5 pounds higher, so there's no real guesswork there. But it's not about exercise, it's about predicted because it's a residual. Because, yeah, residual, the formula is observed minus predicted.
Okay.
I mean, that's not the actual formula, but.
Okay, so we all are gonna agree on number two.
That's
Yeah.
what I've got.
Yeah, that's what I think. Yeah, too. I was reading the lesson and very quick.
Okay, so 29 says for the study previous question, the B1 regression line was 5 pounds. Interpret this statistic.
So B1 is the slope. So that means
Yeah.
5 over 1 is the slope. And
So it goes up by
looking,
1.
looking back, it was the it was how much weight they lost compared to how compliant they were. So I think it's the third one. As percent compliance goes up by 1%,
It
on
goes
average, 5 pounds are lost in 3 months.
by a 1%. Yeah.
Oh.
So I had to draw a little chart. The y-axis was pounds and the x-axis was percent compliance. So we're good with that one, the third one?
Yes.
Yeah, I'm okay with
So question 30, when creating a scatter plot, a residuals plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? Check all that apply.
Oh, this is tricky.
Well, I think we know this one better. Um,
So we don't click the observations are independent?
right, and the x values are measured without error. We don't click that one either. So the residuals are normally distributed, yes, because that's a QQ plot of the residuals. There's a linear relationship between x and y. That is checked with the scatter plot. And the variance of error term is constant for all values of x. What does that mean? Oh, variance of the error term, that is the let's take a look.
I don't know
Oh,
that.
constant variance is the residual plot. So basically, those things check the linear relationship, the normal error term, and the constant variance. I look back at the chart. Constant variance. Okay. Yeah, those 3. So 2, 4, and 5. In fact, we can go back to the other one, the one that I just missed, and double check.
I think I still have.
Yeah, I do. Yeah. A linear relationship between x and y. Variance of the error term is constant for all values of x, and the residuals are normally distributed. Those were the right answers on our last test. So those, I'm guessing, would be the answers here. Okay. So for this next one, I'm going to sum up just a little bit. We're basically taking the airline ticket thing again. So let's make sure we've got that open. But now we're going to do the linear regression thing with it. So we want to predict the price of tickets 14 days before a flight based on the price of tickets listed 90 days before the same flight. So the 90 days is the, what's it called? The, where am I? Is the explanatory variable, and the 14 days is the response variable. So if we take those numbers and plug them into there, we can answer these questions.
So which one starts with 202? Let me see.
Let's see.
The the R value 0.780.
Yep, that's what I've got.
1 7, yeah. 1 7 8.
Create a scatter plot using these 2 variables. Find the correlation coefficient. I mean, a 0.780, it's going to be linear with a fairly strong positive association, right?
So will be
Because all of these say negative or nonlinear. It's not negative. It's not a negative number.
Good test taking skills.
I think it's a non-linear. So
But it's really close to number one.
It's 0.780.
yeah.
Create a scatter plot using these two variables.
Okay, the y-intercept, I get negative 17.087.
I mean, there are some outliers and stuff. We had another one that was shaped like this.
Yeah, but I think it's a non-linear, but
The predicted price is negative money. Wait.
Um, I don't know. Let's try. I'm going to try linear with a fairly strong positive association, and we'll see. 5.6.
Ooh, look at all that traffic, son. Look at traffic.
So are we filling in the y-intercepts and the slopes and stuff like that?
Yes.
Cute bunny.
I got a negative 17.087 for y-intercept.
Oh, I've got 115.640.
What did I do wrong?
One of the errors, son. Oh. It's a bunny.
You have the 90 days on as the explanatory and the 14 days as the response, right?
I think so. I got the same R value, but that doesn't mean very much, I guess.
Some of these it doesn't matter which one. So your very first number under explanatory variable is 234.19.
Okay, I had them flipped. Evelyn,
yeah, I am trying to
did we
because
lose
my
you?
Excel it erased all the information, so I have to write.
Oh, bummer.
Darn
I
it.
sorry, I was trying to do that because I have everything in there, and then it got the information from before.
Okay.
So what I have, um, what was your question? Um, the well, the question from there, I think is well, again, I think it's not linear, but, but I don't
I
know.
know, and that's hard because I remember we had one scatter
We
plot that looked like that, but I
yeah,
don't
I know.
remember what they determined it as.
Yeah, we did put non-linear for that one, and we got it right. It was in last week, maybe. Could be. It looks like. Um, yeah, 90 days. Yeah, I have a very weird thing. Yeah, I will go with non-linear with that one.
Okay, I think I'll go with nonlinear too.
I'm gonna stick my guns, guys.
All right.
See, I'm wondering if they're trying to mess with us because that number looks good. But yeah, the scatter plot looks terrible. I don't know.
I don't trust scatter plots, anyways.
Well, I never know how to interpret them. There are some where I'm like, no, that looks awful, and they're like, yeah, see, it's normally distributed. You're like, oh, okay, say
Yeah,
so.
you think? Mm.
Okay, what is your y-intercept?
The Y intercept that I got. Let me go back.
What'd you get, Evelyn?
Oh, I was just looking at which one was
It's question 33.
0.780. No, that's not the line intercept.
I'm sorry, I couldn't
It's
hear
just
you.
the number. It's just the independent number that is in the formula. The independent number that is in the formula. That's it.
I got 115.64.
Yeah, that's what I've got.
Because it's just that number that you have to add. You don't get it through the Excel, right? Can
Yeah,
I get it like the calculator?
Yeah, no, it's just
One.
on Excel. It's just listed next to it says y-intercept
B
not,
not.
and then under B.
Oh, okay.
Yeah.
Yeah, because I was just doing with my calculator.
Oh, bless your heart.
Evelyn, you are a tough
Okay.
soul.
Yeah, I got that
And then the
one.
slope is 0.627. Is that right?
Yes.
Yeah,
Is
and
that what you got? One. Okay.
1.1 point. Yeah, 1.128.
And then the predicted for the 14 days is
We can just
172.
put in 200 under X on the spreadsheet.
You mean 90, right?
What? No, predict the price of tickets listed 14 days before a flight based on the same flight costing $200 90 days before a flight. So
Oh,
90 days before it costs 200. So what's it going to cost 14 days before?
It's like 0.780.
I got 240.979.
So if you put 200 under X, the predicted is
Oh,
240.979. They want you to round to one decimal place, which is really lame considering it's a price. So 241.0.
Yay!
oh, okay.
Okay.
I got 241.0.
Yes.
Well, 000, the three decimal place.
241.0, yeah. But it says
000.
just to one decimal place.
Okay.
And then, so it says the next three questions construct a 95% confidence interval. So just make sure your 95 is up there. And then we look at the confidence interval under the slope line, the slope row. And I've got, wait, what is it?
0.518.
Yes, lower bound 0.518.
Then 0.735.
Yeah.
That's what I've got.
And then I got
Margin of error.
0.18. 108. 0.108.
Yep, that's what I found.
Yep.
Okay, the next
At least that something familiar.
Determine if the slope of the true linear regression line is not equal to 0. That would be the bottom one.
Yeah. Non-equal.
So for the hypothesis tests, it's always the beta, the big B, B1. So the last one. The value of the test statistic is T. I've got 11.510.
Yes, so do I. And then the p-value is like a really tiny number. It starts with a 4.
Yeah, so I'm just going to put 0.000
Yeah, me too. I mean,
because there's like 19 decimal places of 0. So
Okay,
what do you conclude?
we're almost done.
Low, we reject the null. We reject the null, so there's sufficient evidence
If it's low, reject the null.
to suggest the slope of the true linear regression is not equal to 0. So,
the 90-day.
okay, so the
Linear.
third
I
one?
think yeah,
I
we did this before.
wait. Well, wait. We conclude that there is a linear relationship. Okay, I see. Yes. I just couldn't see the difference between the third and the fourth one.
Right.
Well, is
And just the insufficient and sufficient
Right.
evidence. Question 43. Oh, wait, did I miss something? So for these are just, the rest of these are going to be which test would you use? So this one, in the U.S., mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the program, and birth weight data is recorded. Which hypothesis test would be most appropriate for this study?
one
Uh,
sample
T.
One sample T test. That's what I think, yeah.
Oh,
So many choices.
Can
Oh,
engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure? And as they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline refinery is always 0.03, which is a hypothesis test. So we know this is a Z test
yeah, that's what I think.
because we know our standard deviation.
Right.
Okay, Evelyn, your turn. We lose Evelyn.
I don't know. I was wondering if I lost both of you. Are you there, Evelyn?
Hello?
I'm here. I can hear you.
Um,
She's still showing up as being here.
yeah, she's still here.
Evelyn, if you're here, we can't hear you.
Her phone ran out of battery. Okay.
Well, should we keep going? And I know she'll hop back on.
Yeah.
Ah, there she is.
Hey, where'd you go?
Hey, there you are.
Sorry, my phone died.
Oh, I'm sorry. I was worried my phone died because I didn't hear you, and then Juan wasn't talking. I went, "Oh
Oh
no, my
my
phone died."
gosh. Such an
Well,
idiot.
So what question are you on, Evelyn?
Oh, it's fine. I done it. The next one that you were working on, and I am in 45.
Okay.
okay, good. Number 45. Yeah,
Okay.
that's where we're at.
An attorney wants to know whether a percentage of Walmart employees in Nevada who were over 45 years old is more than 30%. Which procedure would be most appropriate in this situation? This is a test of one proportion.
One proportion.
Yeah.
That's what I think.
Because
Very good, Juan. That's why you got 100% in your test.
not quite 100. Okay, it says a marriage counselor conducts a study of couples, categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative. That'd be so silly if like the non-communicative people like stayed married.
Yeah.
It's like the trick is to not talk to each other. Which of the hypothesis tests would be most appropriate in this study? So we are comparing.
I think we've got two percentages, so we've got two proportions. Because we've got
Chi-squared.
communicative percentage and non-communicative percentage. I can't say the word, but
And the
communicative.
last question of the night. Evelyn, your turn. And Evelyn, she's
Yes,
gone.
sorry. I can read it. The business marketing firm specialized in radio advertising. They hope to show a linear relationship between sales and amount of money a client invests in a radio advertising. Which procedure will be the most appropriate for addressing this question? So they are hoping to show a linear relationship between the sales in each
Right.
client. So the
Chi-squares, right? I'm just
the
kidding.
chi-score.
Anyway.
No, I'm just kidding. No,
No, he's
What?
joking. So linear regression.
it's a
Yeah,
linear.
that will be yeah.
Okay, are we ready, guys? I'm going to submit.
Whether I'm ready or not, I
Yeah.
got it. I got other stuff. Yay! We did good.
That's great. All right, so
I missed 3. Wow.
So hey, look at that. Looks like number 20. We had to round to 13. Ha!
huh.
Are you serious?
Yeah.
Well, why I because in the other thing that we were doing, they say that they always have to run a number. It never has to be a decimal. It cannot be a decimal. It has to be an entire number. That's why.
Yeah, that's kind of weird.
Can you?
But I don't know why you can multiply that by a decimal. I don't see why P has to not be a decimal. So
It has
that's
to
weird.
be an entire number because I don't remember the explanation. I never remember the stupid explanation. It's like this.
Oh, because we were dealing with. Wait, I'm not sure. Oh, question 4. I got it wrong, guys. Sorry.
But I got it wrong
Question
too, and I
4,
agree
that the
with question.
median would increase.
Yeah, I
Wouldn't the
agree.
median increase?
Yeah, because you're making all the.
Making all the numbers bigger. Okay, I'll have to go back and look at that then. So,
Oh, wait, never mind. Guys, the median will stay the same. The mean would increase, not the median. The median number stays true no matter how many numbers you have on the left or the right of it. And in this
Well,
case,
unless that 21 bumped it to have more on one side than the other. You know.
yeah, I don't know. Never mind.
Okay,
Ah,
but you're
You
probably
have
right.
to
You're
go
probably right.
me there for a moment. I got it back to the cell phone.
what?
Okay,
Evelyn,
so
you're all over the place. Hey, look,
Sorry.
Evelyn, it was linear.
oh, you're right. Okay, n. We were solving for n, and you're right. N cannot have a decimal.
That's a part of a
That's
person.
yes. That's stupid. Okay, so Juan, did you get 32 wrong?
I got 32 correct.
Okay, so it is linear with a fairly strong positive association. That's the one you chose, right?
Yes.
Mm.
See,
Wow.
don't trust the scatter plots, guys. Just go with
I
the
know.
R value.
We're trying to make. They were trying to trick us. Okay.
Okay, wait. Just one moment. I just want to show you a picture, and then you need to tell me something. Did you Can you guys see this? So it's like backwards, maybe easy.
No, that's
Um.
fine.
Yeah. Oh
Okay,
wow.
so this is the PowerPoint. Okay, this is just for me that don't mind that one. Um, this is one of the slides, the design the study. This is what we need to do. I just put it on the beginning. I gonna erase it, so don't worry, it's gonna be erased. And I had this picture that you already know, and this other picture that I got today. I think this is a better
Nice.
picture.
That's a great picture.
Looks
And
professional.
then this one is kind of like blurry, so I think it's not as good as the other one, right?
Yeah. No, that other one looked awesome.
Yeah, this one. I like this better though. But do you like the presentation? I choose red and white because we were working with Target,
Yeah, that's awesome.
Yeah.
but I don't know. And then I can include those cards that you were talking about, Juan. That's fine.
Yeah,
And
I'll
this is
put it on the Google Hangouts.
so this is the data collection. And do you like the fonts and the stuff, or you think that it should be modified? And
I think so. I mean, from what I can tell, I can't see it very well because my
uh,
phone. Well, no, it's just my phone is pixelated. It's not because you're not close enough. I'm looking at it on my phone, not my computer. So
okay, so this is I gonna modify. I need to finish this up, but very much I was going to conclude and my conclusions in my actual conclusions, but I didn't actually finish it. But I just want you to have a glance of what it is going to be look like. And if you think no, that looks like very nasty, I hate it, just let me know. I can modify it. All right. I will send you a copy. Okay.
okay,
I
that'd
will
be
send you a
awesome.
copy
Thank you.
and then you guys can tell me if it's oh yeah, you have a very bad grammar. You should like study English before taking any other more classes and something like that. You can tell me. That's fine.
Mm. Ha!
Okay.
No, I think it looks really good.
All right. So and then the question here is the question that I'm gonna put on the front of the page. So that looks okay, or you think that should be in later? Well, I gonna put it later on the other slide, but as a presentation, it's okay, I think, because that way they will know what we are talking about, right?
Yeah, I think having it right up front like that looks great.
All right.
Yeah, good job, Evelyn.
Do you think that I'm going to do the right road? Oh,
Oh
Yeah.
yeah, I
And
think
then
all
so.
right.
don't forget you have the collect the data and the make inferences worksheets to draw from in case.
Yeah, the QQ plot. I just was doing that, Christina, and then see, I put the data for, let's say, for example, this is from you. You see that numbers, and I got a QQ plot that would work different than the ones that you got.
Yeah,
So
it's
I
because you
probably
have
need
to
to,
put them in order from largest to smallest,
Smallest to
yeah.
largest.
or
Oh
even
yeah.
you know.
Yeah, that's what I figure. I was going through the reading and then you guys called me, so I say, oh, okay, I'll do it that later. Okay. So that's all. Then that's
That's
very
great.
much. Okay. Okay, and then that graph that you got, where do you got it? How did how did you do it? They probably tell us how to do it, but I forgot. The last graph, this one.
Yeah,
Oh,
that's
that one?
pretty
I did a search on the internet to find
good.
an F distribution graph that, like a calculator. That's how I did it. They didn't give us anything for that.
Ah, okay. I
So
was
I just
trying to
found it
figure out.
online.
We could probably
So,
share that link on the Hangouts messenger.
Yeah, do I
yeah,
still have it open? Yeah, I'm sure I could find it.
that would be great. Well, for now
Yeah,
I can Google it. Was going to be my next step, but yeah, well, thank you so much. I really appreciate those tips because I wasn't sure that I was doing that right way. That I just listed all of the things that they requirement. I copy paste in here the direction, so I make sure that we have everything that they are asking us for. Okay, so
nice. Yeah,
okay,
that sounds great.
okay. Um, thank you so much, guys, and you guys have a good afternoon. I'll see you. I hope I will we'll all get a good grade in the exam.
Yes. Yeah, good
All
luck,
right.
guys.
Okay.
All right.
You too. Bye.
Thank you.
Thank you.
Bye.